In this video we're going to take a look at the Hidden in Colors challenge on HackTheBox. It's a hard Stego challenge, and the description says, "We intercepted this weird image coming from a person of interest. Can you figure it out, because we sure can't. What we overheard is that the last two digits are of great importance." So let's start by downloading the files. We'll copy this over to our local directory. It's a PNG image, and let's go and do some basic file checks. First of all, let's just look at the image. So it looks like just something that's been thrown together in paint. We can see in the top left hand corner, if we zoom right in, it looks like some binary, which we'll need to try and decode, I guess. Alright, let's have a look. Just verify the file type. PNG image, check out EXIF tool. Nothing of interest. Let's try and run strings. -n8. Nothing. Okay, if we just run strings, we'll get some strings there, but nothing, no strings that are 8 characters or longer. Okay. Let's try and run foremost. And foremost didn't find anything else for us. Let's check out some Stego tools then quickly. So a couple of tools I want to run before we have a look at that binary string in some more detail. I want to run StegSolve, and let's just have a look at the image visually and see. So we can flick through, this is a color inversion, we can flick through the different planes. There's nothing on the alpha. The red plane might actually be useful to us because we can just see the binary string here in just white and black. Let's keep going. Red plane 6, if we go to red plane 6, okay. So changing the planes really is giving us some different visuals here. You can see it looks like this has been created by using like the brush, where the brush size is really big and you like drag it across. Like in Photoshop I've done similar things before. Let's go through the green planes. And then the blue planes. And then we get to full alpha, full red, full green. And we can do random color maps as well. Alright, let's quickly have a look at the stereogram solver. I wish you could zoom in a bit more and just see exactly what's happening to the binary up there, because you can see it's changing quite a lot between these different offsets. Okay, but just out of interest, how far does that go? Alright, yeah, let's close this down for now. We might return to it, and let's just do the ZSteg as well. ZSteg, if you remember, is a Stego tool which deals with PNG files, and it'll try to see what could be extracted. If we run zsteg-a for -all and then pass in colors, it'll basically give some what it could potentially be extracting. Sometimes these are like false positives, but sometimes you might find some reliable files in here which we can then extract by providing these offsets. Okay, so it took a little while to run through that. Actually took a bit longer than usual. I'm just gonna have a flick through, see if anything is standing out to me. Alright, it's not at the moment. Let's go and explore this binary string a little more. So let's go and open up, we can open up CyberChef or ASCII to hex or something of choice, and then let's open up the colors. Let's zoom right in up to the corner here, as far as we can, whilst it's with it still being quite clear. And I'm gonna just make it so we can see both at the same time. Okay, let's. This is kind of awkward because we can't see the binary. Ah, here we go. Here's the binary bit. Okay, so 0, 1, 1, 1, 0, 1, 0, 0. Let's convert that first of all. That converts to a T. 0, 1, 1, 1, 0, 0, 1, 0. 0, 1, 1, 0, 1, 1, 1, 1. 0, 1, 1, 0, 1, 1, 0, 0. 0, 1, 1, 0, 1, 1, 0, 0. 0, 1, 1, 0, 0, 1, 0, 1. And 0, 1, 1, 0, 0, 1, 0, 0. And then 0, 0, 0. Maybe another 0. Oh no, 0, 0. Yeah, I'm going to try 4 zeros there and then 1, 0, 1, 0. Let's try that. Trolled. Oh my god. Okay. Okay, so let's try and move on. Let's close that down. So what else could we do here? Let's check out, there was a StegOnline tool that we used a couple of challenges ago. Let's go and throw our image into this and see if it comes up with anything. So we have some options. We can extract files and data. I mean, this is kind of just similar to what we can do inside StegSolve anyway, but we could say we want to extract the least significant bit of each color channel. We can say what order we want to do it in, LSB or MSB. So if we change that to LSB, we can change this from row to column. Essentially, I haven't explained the LSB technique on any of the Stego videos. So just to be clear, in terms of the Stego technique, if we have an image, let's say for example the image has 100 pixels. Each pixel is basically a value, say between 0 and 255, and then if you have a color image, each pixel has 3 channels, each of which is between 0 and 255. So that's represented, each of those is represented as a byte, so there's 8 bits in it. And the least significant bit is basically always a 1. So if you have a color range to up to 255, then you could encode your data into the least significant bit of each pixel, and the most you're ever losing is 1 bit. So the most you're ever doing is changing the color value from 255 to 254, or from 254 to 255. And then, so say you wanted to encode the letter A, you would find out. Let's go to ASCII to hex. You would encode the letter A here, and this is the binary. So if you had an image that was 8 pixels, and each pixel had a value of up to 255, let's have a look at 255. So here's the value, 255, each pixel has this value. Now let's assume that all pixels are set to 255, which I believe is probably black or white, I'm not too sure, or one or the other. And then we want to encode this letter A. Oh, where's the A? Did it convert? We want to encode this letter A. So in the first pixel, the least significant byte, which they're all 1s, we would change the least significant byte to a 0. And then the second pixel, we would change the least significant byte to a 1. In the third pixel, we would change the least significant byte to a 1, and then the fourth to a 0, etc. And that's how we can easily encode to like the least significant bit without it making much of a difference or any visual difference to the actual image itself. And realistically, you can use like the top 3 least significant bytes without causing any major visual changes to the image. And if you have 3 color channels that you can use, you know, that's you can add quite a lot of data into the image, and then the order will just depend on whether you're encoding as a row. So if you have an image, do you go from left to right, and top to bottom, or do you go from top to bottom and then left to right? And it's just the order. It doesn't matter. It's just whatever order that you embed your data in is the same order you'll need to extract it in, and you'll need to preserve this order. So I did a Stego project a few years ago for my undergrad dissertation, the final year project, where I did some different LSB techniques and some discrete cosine transform techniques and whatever was available at the time. It's a little bit fuzzy in my head, but I basically implemented a few different Stego algorithms and encryption as well, so that you could use a password to actually encrypt the data into the image and retrieve it and stuff like that. It's been a while since I did it, and I still struggle with a lot of Stego challenges, but yeah, I thought I'd just give a little bit of a background just in case anybody's not too sure exactly how this basic kind of Stego technique works. So if this had been used here, we might play around and try some different configurations and try to extract the data. I feel like it's probably not going to be the least significant bit anyway. Let's go back to, can we go back here? Yeah, let's go back and take a look. So we already had a look at the strings. Didn't seem to be much in there for us. Let's just have a look at the description again as well. We intercepted this weird image coming from a person of interest. Can you figure it out? Because we sure can't. What we overheard is the last 2 digits are of great importance. The last 2 digits are of great importance. Okay. Keep going. Show PNG info. Browse bit planes. Just want to flick through this again. Let me just try and view this. Oh. I'm going to just try and save this and see if we can zoom in on that. Is this still just... Okay. This looks like it's saying lol. Lol, lol, lol. And if that was the case and it was digits here, if we were to rotate this, then this would be saying 9. You see that? 9, 9. Okay. Let's have a look at another. Close without saving. Let me try and flick through some of these. Let's have a look at this one, the blue plane. I'm gonna open. Oh, okay, no, not that one. We need to save it here. We'll replace it. Okay. Okay, let me go back and I'm going to open this up in StegSolve again. I wish we could zoom in here, it would be really, really handy, but can we do anything with the frame browser? No, I think this might just be for like GIFs or something. Image combiner, data extract, okay. So we've got a color inversion. It's just going to leave us with the binary. I want to try and find out about this numbers. You can see here, this is like really clear numbers. Let's save this as red7.bmp. Let's save this as red5. This might be interesting. .bmp. Let's take a look at those two. Red5. No, okay. Red 7. It's just the last two digits things that it mentioned there. It just seems quite clear that these are two 9s, but then, or two 6s, I suppose. But then it's not really clear how to decode the rest of it. So let's go back here. Okay, now we get to blue plane 4. Let's check out some of these random color maps. No, alright. Okay, let's move on for now. So now we'll try and open this in Gimp. And we could also do this in Photoshop as well. Okay, I was hoping there might be some additional layers showing here, but there isn't. If we go into the channels, can we... I'm no expert with Gimp, as you'll quickly discover. So I'm just gonna kind of play around with some of the options here. Let's try just with a fill here. Can we... I'm going to pick some color that I don't see any of. Okay, so obviously that leaves our binary data at the top. That was a color that we did already see though. I should have right clicked there, I guess. Or why is that gone to yellow? That's weird. I'm pretty sure I didn't select the yellow color there, but okay. That didn't work. Let's try and select the colors here as well. Can we... So color picker. Use info window. Ah, okay. One thing I want to do is try to combine the hex values of these different colors, which is something which I saw for another CTF challenge from... What was the CTF? Which one was it from? NetForce solutions to NetForce steganography CTF challenges. So there was one which is based on colors, and they opened in Gimp. They opened up the image, and then they combined the various colors HTML notation, which is this hex notation, and we're going to try and do something similar. So we've got our red. Let's grab this. Let's open Sublime. Let's paste that in there. Let's grab our second one as well. Let's paste that in there. Grab the pink. Presumably we're going left to right here, but we could try as well from doing column wise. Let's just put this together first of all. And finally, dark blue. Let's plug this into the ASCII hex. See if we can convert hexadecimal. No. Alright, let's go to crack station. Let's make sure. What length is this? 36. Okay, that's not That doesn't sound too good to me. 36. What about these zeros? Maybe those zeros, that still wouldn't get us. I was thinking maybe if we had 32 there, it could have been an MD5 hash. Let's just throw this in anyway while it's... We might need... Maybe we need the 99 as well from... Okay, let's go back. I just want to check these hex values again. Ones that begin with a 0, would they still count the same? Okay, let's... What about if we put this in hex? What does that come out to? Nothing. And if we put this in, okay, that comes out to something. And this bit, no. Okay. Okay, let's check our hint again. And the challenge is called Hidden in Colors, and we have all those colors there, and it says the last 2 digits are of great importance. So let's go back to our colors, and this time let's just take the last 2 digits of each one. So we've got 24 from the red, we've got 33 from the green, we've got 63 from the pink, we have 30 from the olive, we have 21 from the green, and then we have 31 from the blue. What if we take this and then pass that in as well? We'll try it with hex first. Convert. Okay, we've got some kind of string there. What if we were to do it? If we were to do it in decimal? Yeah. All right. So hex. Convert that. We have a string. It doesn't look like a flag, but let's give it a go. Difficulty. If this is the flag, I'm gonna have to say it's kind of tricky because it still requires a bit of guesswork and kind of put in the really understanding what the hint, how the hint relates to the challenge as well. I'll say medium, and it was, that flag was accepted. All right. Cool. All right. Well, yeah, it was a good challenge anyway. I hope you've enjoyed it. Did you solve this differently? Use any different tools to me? Anything you recommend, you can let me know in the comments below. Thanks.